As you may know, the relays in the industry are fallen into two main categories: the solid-state relays, or SSRs, and electromechanical relays, or EMRs. Of course, if you're an electrician, you may face some other types of relays, such as safety relays, power protection relays, and so on. You may see power relays installed on medium voltage panels, and they are a type of protection device for power systems. They more resemble a controller than a relay. So we can talk about them in detail in another video. We're not gonna also elaborate on the fabrication and manufacturing technologies of the relays, but as always, we're going to see why, where, and how they are commonly used in the control systems by some practical examples. So watch to the end, as I have some great points to share with you. I also strongly suggest you subscribe and click the notification bell. And don't forget to hit the like button. You know all about the history of the control panels were made of only relays and contactors, and regardless of all technological advancements, we still use relays within the control panels. You may ask why we should still use a relay when some PLC cards can switch both the DC and AC loads with different power ratings. Well, listen closely and you'll understand why. Let's first quickly see how electromechanical relays work and get introduced to some essential expressions. You may hear of electromechanical relays as normal relays, contact relays, mechanical relays, and so on. Anyways, it uses a mechanical mechanism to move a, let's say, lever and change the position of some contacts. This movement is made possible by an electromagnet. When we connect the power to the magnet, it attracts the lever, and therefore the NO and NC contacts change their normal or non-energized position. To know more about NO and NC contacts, watch our previous video from the link in the description. When the power gets disconnected from the coil, the lever and the contacts will get back to their initial position. Also, there is a push button on the relay that we can push and test the relay manually without connecting and disconnecting the electrical power. So far, we have discussed the input or primary side of the relay that we connect the control voltage to that. This control voltage is usually from 12 to 110 volts DC, or it could be from 12 to 240 volts AC. But what about the power side of the relay? Let's talk a little bit about the relay wiring diagram here. The power side or secondary side of the relay will be connected to a consumer, or let's say a load. Electromechanical relays in particular are usually used in single-phase applications. Within an electrical control panel, we use them to connect the channels of the PLC digital output card to single-phase AC low-power rating actuators and devices such as solenoid valves, lamps, siren alarms, and so on. We should select the relay in a way that it will match the specifications and power ratings of the load, as well as the control voltage we are going to apply to its coil. For instance, if we want the PLC to turn on this siren alarm according to its logic, we should first check which control voltage signal the PLC card sends out. Let's assume it's a 24-volt DC signal. Then we'll check the siren's power rating. For example, it is 110 volts AC with about 1 amp of rated carry current. So we should make sure of our relay's coil voltage and the amount of electrical current that its contacts can carry. Then we connect the 110 AC voltage from the power supply to the relay's common connection. And from there, we connect the normally open contact of the relay to the siren alarm. Therefore, when the PLC sends the 24-volt DC signal to the relay, the NO contact gets closed, and the AC voltage will be transmitted to the siren. So here is the answer to the question from the beginning of this video: why we should still use a relay rather than solely using a PLC card. In In this example, we use the 24-volt DC control power coming from a PLC digital output card to command to a device with a different level and type of voltage on the other side of the relay. You may say we can choose a PLC card that can switch even the high-rated current loads with 110 AC voltage. Now what? You may notice that we simultaneously isolated or completely separated our control part of the circuit from its power section to prevent damaging our PLC card in case of short-circuit failures. I'll tell you, the cost is a more important factor here. Both the cost of a PLC card with high power rating contacts and the cost of its maintenance in case of high short-circuit failures. It's more reasonable to change a broken $20 relay than changing a $1,000 PLC card, isn't it? Now that you've got your answer, let's see which types the electromechanical relays have. We can classify the electromechanical relays according to the number of their NO and NC contacts. SPST, or single pole, single through. As you see, this could be an SPST-NO relay or an SPST-NC relay. SPDT, or single pole, double through. DPST, and finally, DPDT relays. For example, this is a single pole, double through, or an SPDT contact type. The EMRs have ordinary cube types and a slim 6mm designs to mount on a DIN rail within a control panel, as well as miniature types to solder on a PCB. The ones we install on a DIN rail has made of two separate parts. One is the base that is an interface to connect the wires to the coil and the contacts. The other one is the head housing the coil and the contacts. We can dismantle and assemble the relay easily by pushing the head pins into the base. You can always find the simple connection diagram, the coil voltage, and the other specifications on the head part or just on the side of the relay, and you should use them as your connection guide when you are wiring the relay. That's it for this video. Please, if you liked it, don't forget to click the like button. I suggest you to watch these videos next. Thanks for watching.